in this video we can discuss the quantum theory such as observables and operators, such operators linear operator, identity operator, null operator, eigenvalue, eigenfunction, and commutation operator, and the simultaneous eigenfunction, etc. So we can start it. Observable. What is the observable? Any measurable dynamical quantity like position, momentum, kinetic energy, potential energy, etc. In physics are known as observable. Each observable in quantum mechanics can be expressed as operator from. So next topic is operator. The mathematical operation like addition, subtraction, multiplication, division, differentiation, integration, etc. can be represented by obtained symbol known as operator. Any operator which operates on a function and gives another function. Example: ddx is the operator, and sin x is the wave function. Then this operator operates this function and gives a new function phi rt, or phi rt is equal to cos x. So example is x is the operator, and x square plus 2 is the function, wave function, and the each operation, then the new function is x cube plus 2x, and d is the operator, and x cube is the the operand, or the wave function is equal to 3x square. This is the new wave function, and x is the operator, sin x is the operand or wave function, and each operation then gives to x sin x. This is the new wave function. The next topic is the linear operator. In quantum mechanics, we will deal with system which is considered to be made by linear operator. An operator said to be linear operator when considered a linear operator alpha. Then alpha psi 1 plus psi 2. Psi 1 and psi 2 is the wave function. Psi 1 and psi 2 is the wave function, and this is equal to alpha psi 1 plus alpha psi 2, and alpha a psi is equal to a alpha psi. These both relation holds. Then this operator is linear operator, where psi 1 and psi 2 is the arbitrary function and a is the constant. And their next topic is null operator or zero operator. It is such an operator which each operation the operator operates this function and cannot change this function. The new function is unchanged, so it can be represented as I psi is equal to psi x. I is the I operator is the unit operator or identity operator. Then psi x is the operand, and unchanged the new function. This is the same. So this is the null operator, or this is the unit operator or identity operator. And the next topic is null operator or zero operator. What is the null operator or zero operator? It is such as operator which change the function to zero. That is, the new function is reduced to zero. So a psi x is equal to 0. Then the psi x, is the wave function or operand, and a is the operator. This such operator is null operator, and after operation this function is can be 0. And next topic is eigenfunction and eigenvalue. A operator P operates on the sum function psi, and the produced new function is unchanged but with its complex or real multiply. So P is the operator. P is the operator, and psi is the wave function. Which psi is the wave function, and each operation this wave function cannot change, but it multiply multiply a complex or real multiply. So the function cannot change, but it multiply a real or complex number or multiply. So the psi is the eigenfunction corresponding to the operator P, and lambda is the eigenvalue. This equation is also known as eigenvalue equation. An example: consider the operator d2 dx2 operating on a function e to the power minus 2x. Then we can see that e to the power minus 2x is the eigen function, and the operator is d2 dx2. So d2 dx2 e to the power minus 2x is the function, wave function or operon, and then the result is 4 e to the power minus 2x. So 4 is the eigen value, and e to the power minus 2x is the wave function. This wave function is same, so cannot change. This is the eigen value. This is the eigen value equation. So we can tell that the same eigenfunction can different value of the eigenvalue of the different operator. So the next topic is A is the eigenvalue corresponding to the operator alpha and with associated with the eigenfunction psi x, and B is the different eigenvalue of the same eigenfunction and a different operator. So this psi x is the also known as a simultaneously wave function. Then multiply equation 1 and 2 by beta and alpha respectively. Then we get beta alpha psi is equal to beta a psi is equal to a beta psi is equal to a b psi. Then alpha beta psi is equal to alpha b psi is equal to b alpha psi is equal to b a psi. This is the 3 and 4 equation. So from equation 3 and 4, then we get alpha beta psi minus beta alpha psi. So psi is commonly, then alpha beta minus beta alpha is equal to ba minus ab. This is commonly psi, so is equal to 0. So that alpha beta minus beta alpha is the commutation notation is commutation of the alpha beta is equal to 0, where alpha beta is the commute. What is the commutation? Commute means if two operators measure simultaneously accurately, then they commute. So alpha beta or commutation is 0. But alpha beta are not commute, then alpha beta commutation not equal to 0. Commutation not equal to 0. If that means if two operators measure simultaneously accurately impossible, then they do not commute. Then alpha beta commutation not equal to 0. In Heisenberg uncertainty, we know that the del x and del px simultaneously measure is impossible. So del x del px greater than equal to h cut by 2. But del x del py is equal to 0. That means this is the commute. X and del x and py, x and py is the commute. So it measures simultaneously accurately. But according to Heisenberg, x px is commute. It do not commute. So it cannot measure simultaneously accurately.